Bismillahirrahmanirrahim. Welcome back to the new session. I am Engineer Zarif Khan. Today we will discuss about one-way slab design, that is strip method. How to analyze and how to design one-way slab. So I have presented this in very simple and very easy way, and it will just take 8 to 10 minutes to understand how to design a simple one-way slab using strip method. So first of all, we will start from the material properties and load applications. Suppose we have a simply one-way slab having 12 feet span, and which is supported by the RCC beams on both sides. Actually the grid is 24 feet, but inside in the mid we have provided secondary beams. That is, we have made the slab one-way slab instead of two-way slab to minimize the demand on the slab and to reduce the deflection. So starting from the material properties, the service dead load we assumed 40 pounds per square feet. Then live load we assumed 40 pounds per square feet. This dead load is usually calculated by taking the weight of the tiles, PCC or other structures, other materials on the floor. And here we take this 40 pounds per square feet. Let's see the next is the self weight of the slab. So we assume the slab thickness as 6 inches. So if you assume the thickness we assume is 6 inches, okay. As per ACI code, we have this limitation for the thickness of the slab. Let me share with you the minimum thickness how we can take. This is a table in ACI 318 9.5a. Solid one-way slabs, if this is simply supported, so we can take L by 20. L is the length in inches, and this is the one end continuous. If the slab is one end continuous and other is not continuous, then we will take L by 24. It means that thickness will be a little bit more required here, less required as compared to the simply. The other is both end continuous. If both ends are continuous, so the thickness will be calculated using the formula L by 28, that the total length between the two beams, the total center distance divided by 28. So this is the formula. In our case, the end slab will be like L by 24, but the middle slab will be L by 28. But for simplicity, we will take both the same as, because on the side it is not possible to provide thickness different from the interior slabs. So that's why we will take this greater one. So let's come to the sheet. Here we have a formula. Suppose minimum slab thickness is L by, if I put here, so this is actually this 14 feet. So the clear span between the beams, I have taken this 14 feet, okay. If I take this, this is the clear span because the beam width is 1 feet and the total center distance is 15 feet. So this will be automatically 14 feet. So this 14 feet multiplied by 12, it will be converted to inches, and then by 24. So it is the thickness of the slab. This is the required one, okay. And this is the other the interior slab, this by 28, so 6.43. We will take the maximum one, 7. So we assume here 7. Suppose if I change this distance between the two slabs, I make it 14, so automatically this will be changed to 6.5. If I make it 13, so it will be changed automatically 6. If I make it 12, center distance, like here we have taken 12. So suppose we assume the distance between the supports, center to center distance, as 12, then the beam width is 12 inches. So the ln, or the clear span, will be 11 inches, and the required depth, slab depth, is the 5.5 inches. So we take this as suppose 6 inches. Okay, the concrete strength we assume 3 psi and 3000 psi. Then steel grade is 60 grade. So now this is the material properties, and this is the total factor load. This is actually the dead load is multiplied by 1.2, and the live load is multiplied by 1.6. okay, so this is the total factor load. Now after that, the analysis is made, moment calculation. So we have to calculate the moments. Now come to the moments. We have two types of moments in the slab. One is the mid moment, or the positive moment, and one is the end, or the support moment, that is negative moments. The negative moments is usually more than the positive moments, but as per ACI we have some coefficient which is very easy, and we can calculate these moments, negative moments and positive moments. So as per ACI moments, this I will share with you, that these are the coefficients allowed by the code. According to ACI 8.3.3, so these are the conditions, that what will be the conditions if we assume these coefficients. Like suppose there are 2 or more spans, this condition will be applicable, that if we are having 2 or more spans. Suppose spans are approximately equal, with the larger of the 2 adjacent spans not greater than the shorter by the more than 20%. This is one condition. The other is loads are uniformly distributed. This is other condition. The third is unit live load does not exceed 3 times unit dead load, and members are prismatic. That prismatic mean that not different. Okay, so positive moments, we will take these coefficients. These are the positive moments. End spans discontinuous and unrestrained. This is for continuous, okay, positive, and this is for discontinuous, okay, and this is interior spans by 16. So negative moments, 2 spans, for 2 per span this one, and for 2 more than 2 by 10. So this is negative moments by 10. Actually this moment is greater, -1, and the other is like positive is 1. So let's come here now. Suppose negative moments, we are using coefficient if we are having this exterior span. So suppose this span is actually, if I take this one span, this is the exterior span. So one moment will be here negative, and the other will be here negative. Okay, so these 2 moments will be negative. This is the end span, this is the end span, and this is the exterior end, momentum, and this is the interior end span. Okay, so this one, exterior one, is the end span exterior support is 1 by 24. So here it will be like weight, factor weight into clear span square divided by 24. So this is one moment. And let about the other one, the end span interior support. So in the interior support it will be by 10. Okay, this is like greater, and the other will be by 10 as well. Let me see here. This is by 2 span, this is by 2 more span, this is by 10, the negative moments. So I have taken this negative at other spaces and interior supports. 10 and 11 we can take, like suppose negative moments at other faces of interior supports. This is actually 11. Okay, this is actually 11. So let me make it like this is 11. This is 11. Okay, so this is the interior and this is the exterior one. Okay, so the negative moments we have now, exterior one is 12, this is less, interior one is more, this is 29 and 27, this is approximately same, so we can take this is 1 by 10. So this actually you can say 1 by 10 is actually 0.1%. okay, like suppose we have this one 10, 1 by 10 is equal to 0.1. So 0.1 that is you can say this is 0.1 into this factor load and this clear span square root square. So this is the negative moments, 12 exterior, interior 29, 20, this is all the same. So we will take the maximum one. Okay, the maximum one, let's suppose 29, we will take positive moments. So this is another formula. If we come here for the positive, we have this 14 and 16. Okay, interior span we have 16 and with the discontinuous and integral with support, in continuous and understand 1 by 11. So 14, 16, these are the coefficient for the positive moments. Now come to our calculation. I have taken this one very easy. This is one is like 14. I have taken this 14, exterior mid span 14 and interior mid span 16. So we will take this maximum one 21. This almost very closer. So 14 and this one is 1 by 16. These are the coefficient. So for the safety, I have taken this simple 2 1. For the exterior span, I have taken 1 by 14 factor, and for the interior span, I have taken this 1 by 16 from the code. Okay, so this is simple. Now make it more simple. To make it more simple, I have taken the maximum negative moment and the maximum positive moment. Okay, actually it makes no there's no major difference in the reinforcement and the other. That's why let's take one maximum positive and one maximum negative. So suppose I have taken this maximum negative moment 29 and maximum positive moment 21. Okay, we will design this structure, this slab for these moments. Okay, 29 inch gips per feet and this 21 inch gips per feet. Now come to the design stage. Now we will take, as per the code, what is the minimum area required for a simply one-way slab. Okay, so as per the code, the minimum area required is 0.01002 b into h. B is the breadth, that's 12 inches. Like we take this strip moment, this is 1 inch, we take this 1 inch strip. Okay, so this is 1 inch strip we are taking, and the depth is actually the slab depth. So this is 0.002 b into h. So it means if we I put here, so this is actually the 12 into thickness of the slab. This C12 is actually this one. This is the slab thickness. Okay, so minimum area for this slab is 0.002 b into h, that is 0.144. Okay, if suppose this area is required, so we will calculate moment, how much moment it will will be required for this one. So go reverse. From the area we can calculate this moment. Okay, factor moment, this is a factor moment. Okay, this is the capacity, this is actually the capacity and the demand. So as minimum is 0.01. I have, suppose this is a formula that suppose if this moment is greater than these two moments, so we will go for the minimum area, because this 37.79 is more than 29 and 21. So if we compare, so it means the minimum area allowed by the code is 0.044. So for this area, this moment is required. This moment will be compared with these maximum moments. So this is more. It means that go for the minimum. We cannot reduce the area from this from the steel up this percent. So go for the minimum. This is very simple now. Actually, as per the practical experience in simply supported slab, actually the minimum area as allowed by the code works. So this is very common and very practical. So suppose we go for the minimum area, that is for minimum area, suppose we are using this one area. So if suppose if you use number 3 bar, that is 10 millimeter, so it means the spacing will be 9 inches, the main bar. Okay, if you use number 4 bar, so it will be 17 inches. If you use number 5 bar, it will be 18 inches. If number 6 bar, it will be 18 inches. Why this 18? Because there is a limitation from the maximum spacing as per code, that is 3 into each are 18 inches. Maximum spacing allowed in the simply supported one-way slab is 3 into depth of the slab or 18 inches. So we cannot exceed, even if we use number 8 bar, we cannot exceed this 18 inches. So better that to use smaller diameter bar, that is number 3 or number 4. Okay, so this is the calculation. Now the engineer can provide the bars as per his own, keeping in view the site condition and the safety and the size of the bar. Okay, suppose minimum area does not work, so we have to go for the actual calculation. So this is the actual calculation tables. If suppose this minimum area does not work, okay, so what we will do, we will go for the actual one. So this is the actual one. Suppose this is the area, suppose, okay, the moment we have the moments, and this is actually the calculated area, or area according to the this is A, this 2. So 0.12 is actually the actual one, 0.14 is the minimum, and 0.12 is the actual, and this is for the negative, and this for the positive. This is 0.08 is very less. So it means that usually the negative moment is more. These are the areas for the negative, okay, and for the positive. So if you use the actuals, so this is 11, we in the minimum we use this 9, and here is the same. Okay, another is the shrinkage reinforcement or the temperature reinforcement. One is the main reinforcement, which is provided in the short direction, and one is the temperature reinforcement, that is provided in the other direction perpendicular to the main reinforcement. So the main reinforcement will be in the 9 inches, suppose if we use number 3 bar. The other reinforcement, shrinkage reinforcement or temperature reinforcement, will be this one. So these are the minimum requirements. Number 3 bar 9 inches, and number 4 bar 17 inches. Okay, similarly number 5 bars 18 inches. So these are shrinkage reinforcement and the as required by the code, as required by the minimum area. So I think it's clear now. Just you can take the sheet. This is a spreadsheet. I will share this spreadsheet in the with the video, and you can download it and you can use and you can design your own slab. You can just change this yellow icon. This is from material properties. You can just feed this one, other will be calculated automatically. So just change, suppose I change this load as 5. Okay, I change this load as 5, I can use it. Then I can change this as a 13 feet. Okay, then I can 13. You can use this yellow, you can feed. Okay, 3 you can change to 4. Okay, if you change the steel, so the formula for the thickness is changed. That is we have to multiply with some coefficient, which is not let me share with you. Suppose if we use 40 for fy other than 60, the value shall be multiplied by 0.4 plus fy by 100,000. Okay, so this is another formula. If suppose fy is 40 grade, 40 psi, 40,000 psi. Okay, this is a simple sheet I'm sharing with you, and take it. It is free, and you can design simply one-way slab, and very easy. This Excel sheet, and actually I have made this sheet for the simplicity and for time saving for the engineers, and I would made a lot of efforts on this sheet to make it easy for the fresh engineers and for the people working in the field. And the SI unit, I will make another sheet to convert these units to SI, because many people work on SI units and they don't know about inches and feet. They work on millimeter and meters, and they understand centimeter, meters and millimeters. So I will convert these units to the SI units as well, millimeters, meters and centimeters. So that will be easy for the people who are interested. Some codes actually they are in SI system. Actually we use this feet and inches here in our country. That's why I have made this one in this British units. Okay, thank you so much. Take care. Allah Hafiz. I will request for the subscription and for sharing of this video. Thank you so much. Allah Hafiz.